Hello student, welcome back again social study class. Hope you all are well. Today I am going to teach you again social studies of class 3rd, that is chapter 1, Earth our home topic. Last time we already studied first part 1, that is part 1 of this chapter, Earth our home. So today we are going to study part 2. Okay, we already know about Earth our home. In last class, Earth means it is a planet on which we will live. It is our planet, our home. Okay, so let's move towards contents. Okay, today's contents. So last time we already studied about Earth, the planet of life. What makes up the Earth? On these two topics we already discussed. So today's contents are movement of the Earth. Movement. It means changes. Movement means changes from fixed position of the Earth. We know today Earth will change. We will study about Earth will change or not. Another one is rotation causes day and night. Movement will change. Earth will change. Earth change the position. So, what type of position? Rotation causes day and night. What type of positions will change on day? What type of positions will change on night? Okay, about this also. Another one is revolution. Revolution means changes. What type of changes, what type of movement will occur in Earth? Another one is revolutions causes season. Revolutions means changes. What type of changes will come on summer season? What type of changes will come on winter season? This topic will clear today. Okay, this all questions will clear today. Okay, so this is all about contents. I'll read out from first to last again. Okay, movement of the Earth, rotation causes day and night, revolutions causes season. Okay, this is all about today's contents. So let's move towards first subtopic. Okay, so our today's first subtopic is movement of the Earth. Movement of the Earth. Movement means state of changing. It means changing from fixed position. Okay, so Earth will also change from fixed position. Earth never stands still. It keeps moving all the time. Earth never stands in a fixed position. It keeps changing. The two main movements of the Earth are rotation and revolutions. Firstly, look at the picture. Here is a Earth rotation picture, and Earth rotations on its own axis, the equator and the axis. The black color line from the top up to bottom, this is the Earth axis, which is marked by red color. See carefully. Okay, this is the Earth axis. So the two main movements of the Earth is rotation and revolution. So what is the rotation and revolution? The circular movement of the Earth is rotation. Circular movement. Earth move on a circular directions. Our Earth, our planet, our home move in a circular direction. The circular movement of the earth is rotation. Clear? So, the earth spins like a top about an imaginary line called axis. What? I'll repeat again. The earth spins like a top about an imaginary line called axis. Means, axis means an imaginary line about which a body rotates. The earth rotates on a line. On a line. An imaginary line about which a body rotates is axis. Clear? Okay, I'll repeat again, okay? The earth never stands still. The earth never stands in a fixed position. It keeps movement all the time. The two main movement of the earth is rotation and revolutions. Revolutions means it changes. Rotations means a circular movement of the earth is rotation. The earth spins like a top about an imaginary line called axis. An imaginary line about which a body rotates. It is a axis. Look at the picture carefully, okay? So, this is the movement of the earth. I'll explain you later about rotation and revolutions also. Move towards another subtopic, okay? So look at the picture carefully. Here the earth faces sunlight, it is a day. It is in bright, and the backward, the half earth, it is in dark color, it is a night. That means this picture describe rotations cause day and night. Okay, I'll explain you. Rotation causes day and night. The circular movement of the earth is a rotation. I already told you, earth rotate on a circular movement. Earth move on a circular movement. The spinning movement of the earth is known as rotations. I already told you. Earth takes 24 hours to complete one rotation on its axis. Axis means it is an imaginary line about which an body rotates. I already explained you this also. It is an imaginary line about which a body rotates. Means earth rotates in an imaginary line, that is axis. It takes 24 hours to complete on one rotation. It takes 24 hours, that means one day. It takes one day to complete one rotation. That means in 2 days it completes 2 rotations. That means in 1 year it completes how much rotation? 365 days में 365 rotation. Okay? So earth take 24 hours to complete one rotation. That means 1 day to complete one rotation. When the earth rotates, a part of it faces the sun. This part of the earth that receives sunlight has day. Earth rotates slowly. When the earth rotates, a part of it faces the sunlight. Look at the picture. Only half part of the earth faces sunlight. That part is day. And the half part which is on back side, which did not face sunlight, this is night. It describes night. Okay, I'll explain you again. When the earth rotates, a part of its face the sun. This part of earth that receives sunlight has day. When the earth rotates, a part of its face the sunlight. This part of the earth that receives sunlight has day. Clear? The part of earth whose face the sun, whose receive the sunlight from the sun, it changes into day. And the part of the earth that is away from the sun, that is in backside, which did not receive the sunlight, it has night. I'll explain you again. Listen carefully, okay? Look at the picture. Because of this picture, you will clearly understand, okay? The circular movement of the earth is a rotation. It causes day and night. The spinning movement of the earth is known as rotation. Clear na rotation with this rotation? Okay. Earth takes 24 hours to complete one rotation on its axis. That means 1 day to complete a rotation in its axis. Axis means it is an imaginary line, okay, on which the earth rotates. When the earth rotates, a part of its face, the sun, this part of the earth that receives sunlight, that means a day, that has a day. The part of the earth that has away from the earth, which is on back side, which does not receive light, it has night. So now, what do you understand? What do you think on your mind? So now we receive our light. We are in day. Now, listen carefully. Now means now. We receive light, sunlight at morning. So our earth, our place face sunlight. At evening, earth will rotate slowly. It goes to back side. That's why we did not receive sunlight. So it has night. Okay? So this is all about rotations cause day and night. Okay? Okay. So our next subtopic is revolutions. What? Revolutions. What I said before about revolution? It means changes. Okay? Look at the picture carefully. Here is 1, 2, 3, 4 earth. How many earth are there in solar system? How many earth? There is only one earth in solar system. Okay? But here, to describe, to understood clearly, we make 4 earth. Okay? There is only one sun and only one earth in our solar system. Okay? So move towards topic, that is revolutions. From this diagram also you can understood clearly. Revolutions means changes. I'll clear. Okay. While rotating, the earth also goes around the sun at the same time. While rotating the earth, we already know earth rotates in a circular position. It takes 24 hours to complete one rotation. No? So, while rotating, the earth also goes around the sun at the same time. That means when sun rotates on 24 hours, it goes around the sun also on the same times at that time. Okay? Movement of the earth around the sun is known as revolution. Movement of the earth around the sun. But the circular movement of the earth is rotation, which we studied just before that. The circular movement of the earth is rotation. Earth rotates on a circular movement. But movement of the earth around the sun. Okay, let me clear. How many planets are there in solar system? How many planets? I already told you. I already told you about the solar system planets. There are 8 planets in the solar system. All planet moves around the sun. Like that, Earth also around the sun. There are 8 planets. I already told you what is that. They are Mercury, Venus, Earth, Mars, Jupiter, Uranus, Saturn and Neptune. These all are planets. These all planets move around the sun. That's why Earth also move around the sun. The movement of the Earth around the sun is revolution. Simple. Clear? So, the Earth revolves around the sun in a fixed path. The Earth revolves around the sun in a fixed path. It is called orbit. What it is called? It is called orbit. It is a new name. Orbit. O-R-B-I-T. Orbit. Okay. The Earth revolves around the sun in a fixed path. This is called orbit. Understood? Okay, I will give you one example. You know vehicles, car, van, these all are vehicles. These all vehicles move on road only. You see, these all vehicles are move on road only. We cannot drive our motorcycle inside the house. We cannot drive our van on land or sandy place. We drive in road only because it is a fixed position. It is a orbit of a vehicle. It is a path. It is a way of a vehicle to drive, to move from one place to another. Like that, Earth also move in a fixed position. Also, Earth also move in one way. The way which the Earth move is a orbit. Okay? Clear? Earth also move in a way, one path. This is orbit. Clear? Okay. The Earth takes 365 days to complete one revolution. But just before we studied that, Earth takes only 24 hours to rotate. Earth takes only 1 hour to take one rotate. Rotate is much more different than revolutions. Rotation is much more different than revolutions. Earth takes 24 hours to rotate, then Earth takes 365 days to complete one rotation. That means Earth takes 1 day to complete one rotation, but Earth takes 1 year to complete one revolution. Revolutions means move around the sun. Rotations means circular path. It is a circular movement of the Earth. Earth move in a circular positions also and move in around the sun also. Understood? So this is our revolutions. Move towards another subtopic. Okay? So our another subtopic is revolutions causes season. Okay? Revolutions causes seasons. What is meant by revolutions? What is meant by rotations? We already studied. Revolutions. The Earth takes almost 1 year to go around the sun. The Earth, our Earth planet, take 1 year means 365 days to go around the sun. It is called revolution. Okay? So revolutions causes season. Season, you know season? How many seasons are there? Summer, winter, spring and autumn season. There are 4 seasons. Okay? Look at the picture. Here also describe revolutions causes seasons. At the middle one is in yellow color. It is sun. Others are Earth, our planet. Okay. So we are in April month. Which seasons we face now? Anyone tell me? April. That means spring season. We are in spring season now. Okay. So, when the earth moves, the part of earth that receives the direct heat from the sun has summer. When the earth moves, the part of the earth that receives direct heat. Earth rotates, earth moves slowly. It causes rotation and revolutions in a same time. When the earth moves around the sun, at that time when the earth receives direct heat, sun gives heat and light to us. Okay. When the earth receives direct heat from the sun, direct heat, at that time it has summer. Okay. I'll tell you again. When the earth move around the sun, at that time when earth receives direct heat and light from sun, it has summer. And the other part which does not receive the direct heat, which is on back side, which is on back positions, but when revolutions causes on 1 year only, but rotation causes 24 hours. That means we face day and night, but we cannot face day, summer and winter season in one day, because revolutions causes in 1 year only, 365 days only. That's why. But rotation causes in one day. Okay, clear? When the earth moves around the sun, the part of the earth that receives the heat, direct heat from the sun, it has summer. Like that, the other part which does not receive the heat and light from the sun, which is on back side, it has summer. Okay, simple. So this is all about revolutions causes season. Look at the picture. Here is the summer, autumn, spring and winter seasons also described here. Okay. So let's move toward another subtopic. Are you clear with this? Okay. So now I am going to play a video again. Okay, this is our last video. I'll explain you from this video about the earth, our planet, from the solar system up to revolutions, rotations, all. Okay, how rotations, revolutions cause. You saw just before also, but I'll clear from this video. Watch carefully. Okay.
The vast Earth that we live on appears to be stationary, but in fact, it is constantly moving. Every day, the Earth spins around once on its axis, moving from west to east. This movement of the Earth is called rotation. The rotation of the Earth is what creates day and night, and allows us to see stars rise and fall. Rotation and revolution. Let's say that a person in the northern hemisphere is standing facing south and looking up at the sky. He would see the stars rise in the east and fall in the west. This phenomenon is referred to as the rotation of celestial bodies caused by the rotation of Earth. Imagine that the observer is surrounded by an infinite sky with an infinite radius. We call the infinite sky the celestial sphere. When the Earth's axis of rotation is expanded, the 2 points where it touches the celestial sphere are called the North Pole and South Pole. Every day, celestial bodies rotate a full circle from east to west around the axis that connects the North Pole to the South Pole. This apparent motion of the celestial bodies is called diurnal motion. Here, the term celestial bodies refers to the sun, planets, moon, and stars. The path of diurnal motion created by celestial bodies is called the Diurnal Arc. What would we see if we looked into the sky in all four directions while standing at mid-latitude in the northern hemisphere? First, in the northern sky, we'd see star trails forming concentric circles with the North Star at the center. In the northern sky, stars revolve counterclockwise around the North Star. In the eastern, southern, and western skies, the stars revolve clockwise around the North Star. Recall how the sun rises in the east and sets in the west. Stars rise in the eastern sky, move from east to west in the southern sky, and set in the western sky. Since the Earth rotates around its axis, the diurnal motion of celestial bodies is parallel to the equator, which is perpendicular to the rotation axis. The movement of stars appears different depending on the location from which they are observed. To understand this concept, let's look at the angle formed between the celestial equator and the horizon from the point of view of a random observer. Let's say that someone is standing at 60 degrees latitude. The diurnal arc and the horizon form a 30-degree angle. The path of the stars at mid-latitude is observed based on the equator and the horizon line as defined by the observer's point of view. Let's call the observer's latitude phi. The angle of this latitude equals 90 degrees minus phi, and this angle is also identical to the angle of the diurnal arc. The revolving paths of stars differ depending on the observer's latitude. At mid-latitudes, we can see three types of stars: circumpolar stars, equatorial stars, and never-rise stars. Circumpolar stars do not fall below the horizon, never-rise stars do not rise above the horizon, and equatorial stars float on the horizon. Let's learn more about these stars based on their coordinates. To understand declination, or the coordinates of stars, let's take another look at the celestial sphere. The large circle that passes through the North Pole and South Pole of the celestial sphere is called the hour circle. Declination, which is the angular distance from the equator to the celestial body as it follows along the hour circle, ranges from 0 to plus minus 90 degrees and does not change with the observer's location or time. Thus, celestial coordinates can be marked based on the sun's ecliptic path of annual motion around the Earth and the vernal equinox, the point at which the celestial sphere and the equator intersect. Now let's revisit the idea of circumpolar stars, equatorial stars, and never-rise stars. As we've already mentioned, the movement of stars appears different depending on the observer's location, which means that the types and movements of stars seen at mid, high, and low latitudes are different. Let's say that there is something standing and looking at the stars at a mid-latitude of 45 degrees in the northern hemisphere. The declination range of circumpolar stars, which do not set, is between 45 and 90 degrees, while the declination range of never-rise stars, which do not rise above the horizon, is between minus 90 and minus 45 degrees. Finally, equatorial stars, which regularly rise and fall above and below the horizon, have a declination range between minus 45 and 45 degrees. What about low latitude? In the equatorial region, the diurnal arc is perpendicular to the horizon, which means that all stars also rise and fall perpendicular to the horizon. Therefore, in the equatorial region, all stars above the horizon are equatorial stars. Since all stars rise and fall at the equator, it is the best location for observing the largest number of stars. The last latitudes we will look are the polar regions. The north and south poles of the celestial sphere become the zenith and nadir, respectively. In the polar regions, the horizon becomes the equator of the celestial sphere. All stars move along the horizon, and the diurnal arc and horizon form an angle of 0 degrees. At this location, All celestial bodies above the horizon are circumpolar stars, and all celestial bodies below the horizon are never-rise stars. This is why the polar regions seasonally experience polar nights, during which the sun does not rise, and midnight sun, during which the sun does not set. This is how we observe stars. Group them according to how they travel in the same direction, and mark constellations of stars based on their position in the celestial sphere. Constellations also rise from the east horizon and fall in the west horizon, according to their diurnal motion. Keep in mind, however, that constellations have nothing to do with the actual distance between stars. We also have something called the Planisphere that shows which stars will rise when. The Planisphere consists of a lower, fixed disk where days and months are marked, and an upper rotating disk that displays the times that stars are observed in certain locations. The oval window on the Planisphere shows parts of the fixed disk that correspond to observable constellations. The boundaries of the oval window correspond to the horizon, and the center of the oval represents the zenith. In addition, the lines perpendicular to the horizon inside the oval correspond to vertical circles, and the rotating axis represents the North Star. The sun, which rises after the stars fall, played an important role in timekeeping before the invention of the clock. In the 1400s, the Choson people of Korea used a sundial called the Angbuilgu to figure out what time and season it was. The Angbuilgu is a concave sundial with the tip of the gnomon facing the center. The tip of the gnomon points toward the north pole of the celestial sphere. 12 hour lines are drawn vertically inside the sundial to indicate the time, and seasonal lines are drawn horizontally to indicate the changing seasons. In this way, Koreans could tell what time and season it was by observing the shadow cast by the gnomon. Up until now, you may have assumed that all people living on Earth see the sky in the same way. It is fascinating to learn that the night sky and stars we see differ by location. From now on, when you travel, take a moment to pay attention to the night sky and the stars you see. Next time, we will take a look at the Earth's revolution around the sun and the sun's annual motion. Stay tuned for the next lecture in the Why series. Series of Why.
So, thank you so much for watching video clearly. I hope you all understand clearly from this video about the Earth, our home. So now we finished our today's class. Also we finished our chapter, the Earth, our home, part 1, part 2 both. So see you on next class. Okay, bye. Activity. Okay, are you interested? Okay, we'll do one activity. Okay, I'll ask you questions. Answer is it in right side? Choose the option. Okay, tell you one answer. Choose. See carefully. Okay, fill in the blanks with given option. This is our activity. So question number 1. The Earth is known to be the planet of dash. The Earth is known to be the planet of dash. What is the answer in your views? There are many options. Answer in right side. Choose one. Okay. The Earth is known to be the planet of. Yes, the correct answer is life. The Earth is known to be the planet of life. Okay. The layer of air that surround the Earth is called dash. The layer of air. I already told you. all about that. I already described you. The layer of air, I told that what we exhale, inhale, and in our surrounding, what I already told you about all this air. The layer of air, the main question is layer of air around the earth. Layer. It is, yes, the correct answer is atmosphere. The layer of air that surround the earth is called atmosphere. Okay. Question number 3. Dash of the earth has water. Dash of the earth has water. What is meant by that? The dash of the earth has water. Okay, I'll give you hints. Okay, dash percent of the earth has water. In earth there are dash percent of the water available. We found dash percent water. Yes, we found 3/4 of the earth has water. 3/4 of the earth has water. That means 70% we found our earth water only. That's why we call blue planet. 30% land we found. Okay. So another is dash is the air we breathe. I told you just before. But I did not told you what we breathe. You should give answer. Dash is the air we breathe. What we inhale? Yes, the correct answer is oxygen. Oxygen is the air we breathe. Okay. So another one, which last one is dash is the fixed path on which the earth revolves around the sun. Dash is a fixed path. I know you all know this answer, this last answer, because I give you example also. One path, one way. I give example of vehicle. The fixed path on which the earth revolves around the sun is orbit. Very nice. The orbit is a fixed path on which the earth revolves around the sun. Okay, this is our today's activity. So let's move to our another subtopic. Okay.